Alright, in this video we're going to take a look at how to solve a system of equations using what are known as inverse matrices. So long ago you learned that to solve something like 5x equals 10, you're going to divide both sides by 5. Since x is being multiplied by 5, you do the inverse operation of multiplication, which in this case is division. You could also think of it as multiplying both sides by 1/5, and you'll get the same answer of x equals 2. Now, with matrices, we talked about adding, subtracting, and multiplying. We don't technically divide matrices in this sense, but we do need to use an inverse operation in order to solve the examples in the previous video. So those systems of equations that we wrote as matrices. So before we do that, I can take a little detour for a moment and talk about what are known as identity matrices. And an identity matrix is a square matrix, so the same number of rows and columns, with ones along the diagonal from the top left to the bottom right. It's also called the main diagonal, and then zeros everywhere else. So for instance, here we have a 2 by 2 identity matrix, which we denote I sub 2. We usually use I for identity matrix. Notice from the top left to the bottom right we have ones, and then there's zeros elsewhere. Here's a 3 by 3 identity matrix where we have, again, ones along this main diagonal from the top left to the bottom right, and then everywhere else we're going to put a 0. So that's what we mean by an identity matrix. And one of the properties of an identity matrix is, like with matrix multiplication, if we multiply a matrix, let's say we multiply a 2 by 2 matrix by this identity matrix, it's going to give us back that 2 by 2 matrix we started with. So it's like multiplying by 1 where it doesn't change anything. So the inverse matrix for a square matrix, which is what we're going to use to help us solve these systems, for the inverse matrix for a square matrix A is going to be A inverse. So we've talked about inverse functions. Here we're talking about inverse matrices, and we're using the same notation where it looks like it's being raised to the -1 power, but it's actually the notation for our inverse matrix. So a property of inverse matrices is that if we multiply a matrix by its inverse, we get the identity matrix. And even though we talked about in a previous section that the order in which you multiply matrices makes a difference, here if we did A inverse times A, if we switch this order, we're still going to get the identity matrix. So not all matrices follow that where you can switch the order and the result won't change. Most of the times when you switch the order of multiplication, the results do change. Here, they won't. So in our matrix, in our last video, we wrote the system of equations as a matrix multiplication problem. So we had a matrix A, which was the coefficients, times matrix here X, which would be our variables like X and Y or X, Y, Z. And then matrix B was our answers that we had on the right-hand side. So again, A is the matrix of coefficients and B were the constants on the right-hand side. Then solving for A, if we multiply both sides by A inverse, we get X equals A inverse times B. So here we're going to want to use the inverse matrix first and then multiply by the matrix of the constants on the right-hand side. So we are going to go in this order. So we're not going to discuss in this video how to actually find the inverse of a matrix without using a calculator. Maybe in a future video, I'll kind of go over the ins and outs of how to find the inverse without using a calculator. But in this video, we're not going to dive into that. So example 2, solve each of the following using matrices. So we had our, I believe this is our example 1A, so now we're actually going to solve it. So from example 1A, we filled in the matrix A as 0, 4, 1, and then -4, -5, 5, and then 6, 5, 0. And we're multiplying that by X, Y, and Z. So this 3 by 3 matrix would be A times this matrix here is X equals, this is matrix B over here on the right. And so to get the variables X, Y, and Z, we need to multiply the inverse of A by B. So in order to do that, we're going to use Desmos. I'm going to go back to this one so I can remember what's in there. However, normally we use the calculator, graphing calculator for Desmos. What you're going to want to do is in the address bar where it says desmos.com, switch it over to matrix. So desmos.com/matrix, and it should give you a matrix calculator. So it's still in beta, which means they're still working out some of the bugs. But this will allow us to work with matrix calculations, especially for solving a system of equations. So we're going to want to put in a new matrix, and it's 3 rows, 3 columns. So add it to it, and it even gives us the same A. And we have a couple choices for the variables, the names. So we have 0, 4, 1. So we'll go 0. Then I think I can just tab. If not, you can just press press where you want to go. 0, 4, and 1. And then in our next row, we have -4, -5, and 5. So -4 and -5 and 5. And then in our third row, we have 6, 5, and 0. So 6, 5, and 0. So then we'll just press enter, and it's registered. And then we want to put in matrix B as a 3 by 1 with -1, 0, and 25. So we want it to be 3 by 1, and we want -1, 0, and 25. So -1, tab, 0, tab, 25, and press enter. Okay, so now it's registered, matrix A and matrix B, and what we want is we want to have the inverse of matrix A and multiply that by matrix B. So to get the inverse of A, we hit A and then the inverse, and then we're going to multiply that by matrix B. So what we get are 5, -1, and 3. And those are our values for x, y, and z. So if we go back to our original problem, if we plug a 5 in for x, a -1 in for y, and a 3 in for z, it's going to make each of these 3 equations true. So again, now we have x is 5, y is -1, and z is 3. All right, part B, we have x minus y equals -9 and -3x minus 4y equals -8. So writing this as a matrix equation, we're going to now put in matrix A as a 2 by 2. So let's go ahead, and I think I can clear out. There we go. Okay. So matrix A is a 2 by 2. And the values are 1, -1, -3, -4. 1, -1, -3, whoop, -4. And I'll just go ahead and change that. And then matrix B is -9, -8. So matrix B is 2 by 1. And it's -9, -8. And now we want the inverse of A times matrix B gives us -4 and 5 as our answers for x and y. All right, part C, we have this new matrix equation, so at least we don't have any missing variables to fill in with zeros. Alrighty, so pretty much the same technique. I'm going to just clear this out. New matrix A is going to be 3 by 3. And let's see, we have 1, -3, -5. So 1, -3, -5. And then we have -2, 3, and 5. So -2, 3, and 5. And -1, 3, and 6. So -1, 3, and 6. All right. Everything's good. Matrix B is -18, 23, and 17. That's a 3 by 1. So I've already forgotten what they are. -18, 23, and 17. All right. And now to get the solution for this system of equations, I want to calculate A inverse times B. And doing that, we get A inverse times B gives us -5, 6, and -1. Yep, -5, 6, and -1. So our final answer for example 2, x is -5, y is 6, z is -1. If we plug each of those 3 values in for x, y, and z in each of these equations, all three equations will come out to be true statements, where the left and right sides both come out to be the same numbers. So in this first one, the left side would be negative 18. The second one, the left side would come out to equal 23. And the third side, the third equation, the left side would come out to equal 17. All right, so that about does it for this video. Thanks for watching. I'll see you next time.